Hi guys, happy Friday. I just want to go over the work for today before you attempt anything on IXL. So at the beginning of the week, if you came to the Zoom session, we had discussed that when we graph a system of equations, up to this point, we've always had one solution. If the two lines cross, they cross at one specific spot, and that's called our solution. But there are cases where we might have lines that don't cross at all, or we might have lines that wind up being exactly the same line. So I'm going to go over those two special cases because that is what you will be practicing on IXL today. So if you take a look at the example here, parallel lines, and we've discussed this before, that parallel lines have the same slope. So it says if the two linear equations have the same slope and different y-intercepts, that's important, the lines will be parallel. Since parallel lines never intersect, the system will have no solution. So here is an example of a system of equations that wind up having no solution. If you take a look at the equation y equals 2x plus 4, we have a slope of 2, and we have a y-intercept of positive 4, so that's indicated by the line in blue. And if I take a look at the second equation, y equals 2x minus 2, I also have a slope of 2, but notice the y-intercepts are different, and that's indicated by that line that's like in a burgundy color. So because the slopes are the same, they wind up being parallel. We can only have a solution if the two lines intersect at some point, and that's not the case here. So that's why we have an answer of no solution. And that's what you would write. If the lines don't cross, you would have no solution. So let's take a look at a couple of examples that are similar to this. So in this first example, y equals 2x plus 3. It's already in slope-intercept form, so I can see that I have a slope of 2 over 1 and a y-intercept of positive 3. So positive 3 will be the first point that I plot, and since the slope is positive, I will go up 2 and to the right 1 to get a couple of points going in that direction. I'm definitely going to go back to the y-intercept and go down 2 and to the left 1 to get some points going the other way. And then I want to actually graph my line. And I'm going to extend it to make sure that the two lines cross once I graph the second line. And my equation for this line is y equals 2x plus 3. Okay, so for my second line, we have y minus 2x equals negative 1. So now in this example, it is not in slope-intercept form, so I will need to get the y by itself. So in order to get rid of the negative 2x, I'm going to add 2x on both sides. And on the right-hand side, I'm going to be putting my x term followed by my constant. So I have a slope of 2 over 1 and a y-intercept of negative 1. So if I go to graph this line, after I plot my y-intercept of negative 1, I'm also going up 2 and to the right 1. So if I go up 2 and to the right 1, or I go back and go down 2 and to the left 1, my two lines are never going to cross. Okay, and that is because the lines are parallel. So when you're graphing that first line, you can't assume that they're going to be parallel. So you definitely want to make sure that you extend the line in both directions. Okay, but in this case, they are parallel. They have the same slope, but different y-intercepts. They never cross. So this would be an example of a system that has no solution. Okay, let's take a look at a different one. And if I take a look at this equation up top, I have x minus 2y equals 4. There's something similar to this on IXL, I believe, so I just wanted to go over how you would solve this because we haven't done this in a little bit. So again, it's definitely not in slope-intercept form, so I do need to get rid of the x on the left-hand side. So my first step would be to subtract x on both sides. I'm left with negative 2y on the left and negative x plus 4. Remember, we're putting the x term followed by the constant. I still need to do some division here, so I have to divide every term by negative 2. Keep in mind I have an imaginary negative 1 in front of that x, so I'm going to put that in. So now I can see that I have a slope of negative 1 over negative 2. But remember, we never write two negatives, so a negative divided by a negative is a positive. So I'm going to just rewrite the slope as 1/2 x and then minus 2. If I take a look at that line, we have a y-intercept of -2, and I have a slope of 1/2, so I'm going to be going up 1 and to the right 2. I'm going to go back, and I'm going to go down 1 and to the left 2 to get some points going in the opposite direction. Okay, I'm going to graph my line. I'm going to label it with the original equation, x minus 2y equals 4. Okay, I'm noticing here that I have a typo, so I am going to change this -2 at the end to +2. Okay, so we have y equals 1/2 x plus 2. So I have a slope of 1/2. I have a y-intercept of +2. So now my first point will be at +2 on my y-axis. Slope is positive, so I'm going to go up 1 and to the right 2 again. So that's exactly what I did with the other line. If I go down 2 and to the left 2, you're going to find that these two lines are going to be parallel as well. So when I connect my points and extend my line, label it, I can see that I have no solution again because my two lines do not intersect. Okay, let's take a look at a little bit of a different, not a different situation, same situation, but different equations. We haven't graphed horizontal and vertical lines in a while either, and this might come up on IXL as well. So just remember, if you are ever graphing an equation that just has a y in it or just has an x, those will always be horizontal or vertical lines. So if you recall when we did this, we kind of described it as every single y value on that line would be 2. So it doesn't matter what 2 points I picked. Let's say I picked 1, 2, and -3, 2. If I plot those 2 points and connect them, you're going to notice that I have a line that goes through 2 on the y-axis. If I take a look at the equation y equals -3, and I pick any 2 points that have -3 as the y value, let's say pick 0, -3, and 5, -3. I'm going to have another horizontal line. All right, so these equations where we just have y set equal to a certain value are always going to be horizontal lines, and because they're both the same type of equation, they are going to be parallel as well. We technically have a slope of 0. If you recall, horizontal lines have a slope of 0. So because of that, we are not going to have a solution here as well. Okay, now the flip side is if I have equations with x's in them. So here I could come up with 2 points that have x values of -5. I can pick any 2 points I want as long as the x values are -5. So I have -5, 0, and I have -5, 3. If I connect those, I'm going to have a vertical line. And for my equation, x equals 1, if I pick points like 1, 6, and let's say 1, -2, I'm also going to form another vertical line. Okay, so anytime you have the equations where you have x set equal to a number, you're always going to wind up with vertical lines. If you recall, vertical lines have undefined slopes. So since both of these have the same type of slope, they will not cross either. And therefore, for this type of problem, you would have no solution as well. All right, so there are a couple of problems where the answer would be no solution. Okay, let's go on to our second special case with systems if you have the same line. So if the two linear equations have the same slope and the same y-intercept, the lines are exactly the same, the equations represent the same line. This system will have an infinite number of solutions. So think about it. A solution is when two lines cross or two lines intersect, the number of points the two lines share. If these two lines are exactly the same and fall on top of one another, they share an infinite number of points, so therefore there's an infinite number of solutions. Now this equation here, y equals -2x plus 1, we can see we have a slope of -2 and a y-intercept of 1. although this equation may not look the same, when I actually subtract 2x on both sides to get the y by itself, I do wind up getting the same exact equation. Okay, so sometimes it doesn't look like they're going to be the same exact line, but once you get the y by itself, you're going to notice they are. So because they share an infinite number of points, we have an infinite number of solutions. So let's take a look at a couple of examples there. So in our first equation here, I have a slope of 2 over 1 and a y-intercept of -4. Slope is positive, so I'll go up and to the right. That was already in slope-intercept form. So I'm going to plot my y-intercept at -4, go up 2 and to the right 1. And I'm going to label that y equals 2x minus 4. Got cut off a little. If I take a look at the second equation, it's not in slope-intercept form. So I am going to have to solve for y. So if you notice, in order to solve for y, I would have to use my inverse operations. The opposite of multiplying by 3 is to divide by 3. Every single term gets divided by 3. So I wind up with y equals 2x minus 4. So if you notice, even though it didn't look the same initially, it winds up being the same exact line. So again, I'm going to have the same exact points. I'm going to have the same exact line. And we can label that 3y equals 6x minus 12. So there is an example where we would have infinitely many solutions. Okay, let's take a look at one more. If we have y plus 3x equals 2, we will have to solve for y first. So first step, subtract 3x on both sides. I'm going to write the x term followed by the constant. So I have a slope of -3 over 1 and a y-intercept of +2. So from my y-intercept, the slope is negative. I'm going to go down 3 and to the right 1. I'm going to do that a bunch of times. I can also go back to the y-intercept and go up 3 and to the left 1 to get points going the other way. So I have y plus 3x equals 2. Unfortunately, my second line is not in slope-intercept form either. So in this case, the 2 is being multiplied by the y, so the inverse, like in the last example, we have to divide everything by the coefficient, so we're dividing by 2 in this case. We have y equals -3x plus 2, and lo and behold, you wind up with that same exact equation. So again, I'm going to have a y-intercept of 2, I'm going to have a slope of -3 over 1, so I'm going to wind up with the same exact line. And that equation is 2y equals -6x plus 4. All right, so sometimes it's hard to tell whether you're going to have lines that have one solution, no solution, or infinitely many. So the key is to make sure you solve for y correctly, plot your y-intercepts correctly, use your correct slopes, and then you'll be able to determine the number of solutions. So in this case, we have infinitely many solutions. Okay, so hopefully this will help you out with the IXL lesson for today. If you have any questions, just take a snapshot. You can send it to me, and I will get back to you as soon as I can.